Welcome back, everybody, to Scripted to Rust YouTube channel. We are here with Jochen Deister today, who has successfully finished the Rust cohort. 6 weeks of writing a lot of Rust, getting a lot of epiphanies, and we wanted to talk with you today, Jochen, about your experience and some of the things you learned. And so thanks for joining us today.
Absolutely. Thanks for having me.
Yeah, feels like a podcast. I guess this is a podcast. But yeah, you have quite some experience in Python coding for a long time, right? So tell us a bit what got you into Rust. What piqued your interest?
Yeah, I would probably more say I have a decent experience in Python. I know my way around, and that's also why for a long time when you nudged me and said you're learning Rust and I should give it a go as well. I thought I have still so much to learn in Python, and putting another language on top of that. It's kind of like learning two languages when you don't really know the first one and you start confusing concepts. And I also heard a lot about Rust that it had a notoriously steep learning curve. And I'm doing this for fun, so why should I punish myself like that? But then just 3 months ago, I listened to the last episode of the PyBytes podcast, and there was this offer for a lifetime access for the Rust platform for $49, and I was literally sitting in my easy chair and rocking away, listening to the podcast. Oh wow! Lifetime access, $49. I'm in. I can use it for a lifetime. So that's actually how I started. It kind of tells you a bit about what my triggers are. And then when I had the Rust bytes, you kind of get sucked into it, and then from completing the Rust platform, the next step going into the Rust cohort was it felt very, very natural.
Interesting. But that marketing worked. Okay.
Yeah, at least on me.
you were indeed very disciplined, finishing all the 61 exercises, very methodical, and and then indeed we had a chat like, maybe you should tackle something more, interesting. Because the bytes are small and they're just like little functions, and you learn the concepts, right? But then of course the step up is to do a complete project, which in our case is the JSON parser. So you did that, and we'll talk about the results in a bit because they were quite stellar. But tell us a bit what happened then when you joined, and 6 weeks of week by week. How was the curriculum so effective for you?
Yeah, so the curriculum is really, really well laid out, and I'm saying that with somebody coming from years in academia and teaching experiences. Not only do you learn new concepts, you also learn how to go about them, and the curriculum docs are laid out with a clear goal at the start, with a theoretical part afterwards that has room to dive deeper, and then an implementation strategy and implementation steps, plus success factors also. And that really worked for me very well because it gives you a balance of guidance and freedom, because everyone in the cohort implements this towards the same goal, but the way they go about it can be quite differently. And so it allows for people going this path or going deeper here, or just scratching the surface. And that really worked very well for me. I started on the first day reading the theoretical background materials, and then I worked with Notebook LM to create podcasts on the theoretical background, or on documentation pages, and then you start implementing and just iterating over it. And so when the new week dropped on a Thursday, I was typically done fairly decently on a on the Saturday already, and then took the Sunday, Monday for fine tuning, and really come prepared for the cohort calls on Tuesday afternoons.
Cool. And how was that progression? Because you shared some really good wins on Slack. For example, you really liked the Rust documentation.
Yeah.
You were profiling. You actually felt right at home with Rust as well, right? So maybe can you talk a bit about what you like so much about Rust and how it influences how you write programs now with this new knowledge and skill?
Absolutely. So my first computer, I'm obviously fairly old, and my first computer was a Commodore VIC-20, and I had like 6 kilobytes of RAM. And I remember the first time I filled the whole memory with code, and it felt amazing, and it felt very limiting. And that, working with such a memory constraint, and the second computer was a Commodore 64, which was a lot better, also for gaming, but you still had to work. You still had to play with the memory to get stuff done. And I moved on to a Schneider PC. I can't remember the processor there. And then the challenge didn't, move from the memory constraint to the speed constraint. And that's when I looked at, maybe I should write this in assembly, and instead of Turbo Pascal at the time, or COBOL. And so a long time ago, I worked with these very low-level stuff, and then my life turned into something else, and I became a lawyer and forgot all about coding until I picked up, Python some 8-9 years ago or something like that. And Rust and Python abstracts a lot of these concepts away. It claims to be developer friendly because of this, but it hides the mechanics, and it hides the way the different ways you can improve your code. And the beauty of Rust is that you've got the hood right open, and that also means the compiler is sometimes in your way, because something that's inferred or guessed in Python doesn't really work at all in Rust. And I've never had the feeling that I was fighting the borrow checker, for instance, as people say, or the compiler and the error messages were my friends right out of the gate, because they often had a very good explanation of the error, but also a hint where you should go, what you could do differently. And that clicked a lot more with me than it did with Python. Plus, I think Rust is so much more. It's a beautiful language. When you look at it and you work with an iterator and you have all your steps laid out underneath, you can get it right away. Even though it's so strictly typed, you understand what's happening and how it's happening, and you can chain commands. Like in functional programming, and for some strange reason, that is a lot more how my brain seems to work, and that's why I really fell in love with Rust. And again, just 3 months ago, I was sitting in a lazy chair, zipping on a cup of tea, and thinking Rust is for people who want to be punished in their lives. Here we go.
So the constraints of Rust really ended up being your best friend.
They never felt as constraints. They felt as guiding principles for better programs.
To unsloppy your code, maybe?
Yeah, absolutely. Really think about it. What do I need? Do I need to own this value, or can I just borrow it? It's something you don't think about in Python. You have all the other problems that come with it when you declare, when you pass a variable around, and Rust forces you to think that through, and that makes it so much clearer. It makes the concept in your head a lot clearer what's happening. The first time I came across, I built something with whatever, Flask or Django, and there's magic happening. There's literally magic happening in one line, and you don't understand what's happening and why it's happening and what the problems could be. That's in Rust a lot more on the surface, and that helps to write better programs.
And that's forces you to do that before you even run it.
Yeah, absolutely. Yeah. It's fascinating. I mean, I use a very minimalistic IDE for us, the Z browser, or Z IDE rather, and it has very limited functionality, or not limited, let's say minimalistic functionality, so you can really focus on the code, and it doesn't get into your way with a lot of AI and code suggestions and type hints and what have you. And but what it does in the background, it runs the cargo Clippy, and it shows you in the bottom layer if you have any errors, and you click on it and you see the errors with the error messages, and so that's really super helpful. Yeah.
Nice. And how did you go about? So I mean, the compiler was also kind of your pair programmer then, right? Because people say to get the most out of the program, you should use AI as a learning tool, of course, not to help it write your code. So you were very, from the bytes on already, right? Very deliberate about writing your own code. And I think you're also a bit more skeptical about AI models these days, as we've spoken about, right?
Yeah.
So yeah, tell me a bit about that learning experience and how to responsibly use AI with this, and that side of it.
Yeah, I didn't really use AI. I didn't really have to use AI as a coding tool. I use AI as for Python. I have created a skill as a Python mentor, which has certain rules that tells me only I write the code. Yes, only I write the code. You guide me. You don't spoiler solution code, or let me find the solution. And you also point at documentation, and that skill, the shorter the context window becomes at the end, the adherence of Claude or Codex really goes down. And so I use generative AI on the side to supplement it. Like, for instance, I use the Notebook LM as a tool to create podcasts from documentation pages. You'd be surprised how well these podcasts are if you feed it an API documentation. It's really amazing. Even though they always say C+++. So I don't know that language yet, but who knows? Maybe Google knows more than we do. I'm sure they do. And then I also create flashcards with that on a documentation of a documentation page, and I create like 60 flashcards. And because it's based on a real source, there's no hallucination, basically, and that helps to deepen it as well. But to just give you an example, when I was working in the final steps in week 6 on the performance of increasing the performance of the parser, and I had 4 data sets, 4 JSON data sets. 3 of them were faster already in Rust than in the Python equivalents, and I was just fighting with the last one to get it down. And so I took a step back and said, maybe I just need to borrow the whole input. And then instead of owning it and having to copy it onto the heap, which is memory intensive, particularly with long JSONs. So what I did is I changed sort of just the entry point, gave it the lifetime and a borrowed string, and then I ran the cargo check, and it gave me 78 errors. But those 78 errors were my path of what I needed to fix to get to the result. and suddenly you change something up in the chain, and your 78 reduced to whatever 50, and so on down the line. But it is your implementation guide, and of course, 78 errors at the beginning you might say, maybe I should try something else. This seems very, very broken. And yes, it's very, very broken because I broke it deliberately at the first step. And that's something that's also changed in the Rust cohort, where I wasn't trying to solve it and then run cargo check. I was more going back and forth and seeing what's the effect of that my change has. Does it let the error message go away? And yeah, that's why I said, I think you put it correctly, about the compiler is your pair programmer in a way.
Yeah, amazing story. It's almost like having the best 200% test suite in Python, right? Where you make a little change, it starts to scream PyTest all over the place, but you have that almost for free because of the strictness, right?
Right.
Amazing. Yeah.
Yeah, and the typing. That's what you were coming across there.
Correct. Yeah.
So talking about performance, in the last week you went pretty far to make it faster, right? Faster than C in the end. So do you want to? What do you feel when you saw that you hit that milestone?
Yeah. So it's kind of like lifetime offers. Setting such a goal is also a trigger for me. So I didn't. Everybody was in bed already. It was Sunday night. I'd been working on the parser for 4 days on and off, and I just couldn't get it to improve. I looked at the last week's 6 commits. I have close to 30 commits, and every commit is literally one step trying to improve it. So what I realized in the process was, Rust is not per se faster. Just because it's Rust, it doesn't mean it's faster. It's the coding style. It's being a more deliberate developer, thinking about where a lot of memory is used and allocated and wasted essentially. And that's when I came across a tool as a profiler, and I've heard people talk about that, but I've never really used it myself. And that's also one part of why I think the Rust cohort helped me step up a whole big step in my developer journey, so to speak. And you can really see, you can see this line has, 20% of the usage here. So I need to focus there and not somewhere else where I think it might be. It's very kind of like data-driven improvement. And it comes with, you have to be persistent, So I initially had an idea, have a vector, which is like equivalent of a Python list, and I turned that into a double-ended queue, like a deque. And so I can pop in front and I can push in the back at the same time. And it sounded like a really good idea, and it made sense from looking at the performance. And then 2 days later, when I looked at the profiler, that very line that I was so proud of was now by far the biggest offender. And of course, that can be frustrating, but it's also fun to see, okay, maybe there has to be a better way of doing that. I also came across something, in the profiler, it's always the hash map, and you go down, it's all like, goes hash brown at everything. And so lots of calls for, what in Python would be a dict. And then I thought maybe there's an alternative to what we have as the hash map in the standard library. And I realized by reading the documents, the documentation, that hash map the built-in hash map, or you have to still use it, but it's in the standard library sort of has a lot of security code to prevent distributed denial of service attacks, DDoS attacks, which is totally useful when you write a web framework. But I wasn't. I'm writing a command line tool, so this API is never going to be exposed to anything outside of my machine. So I don't need that. So and then I replaced it with another hash map tool that was more stripped down, and then that again led to learning how to instantiate a hash map and understanding how that's actually done and the hash elements in there. And it's been a long way. But when the moment that you run the benchmark suite, and suddenly it reads 1.84 faster than Python, or in for some data sets it's 3.5 times faster. That is amazing. That's such a dopamine rush. And again, particularly 3 months ago, I was sitting in a rocking chair going, why should I learn Rust? And here I am, just a couple of weeks later, writing a program that is faster than the CPython implementation of a parser. It's freaking unbelievable.
And across standard data sets too.
Yeah. So I used to, I thought I'm not. If I do this, I'm going to do it right. And then I looked for what the real data sets are. Canada, Twitter, the CITM, very small JSON, and realized why they are the standards, because they're fairly different. And that's why I went down some rabbit holes of, I thought, I know how long a Twitter tweet is. So I know what the maximum capacity is that I need on the heap. So I'm just going to plug in that number, 256. And the Twitter performance went up, obviously. The rest went really down because I was just, wasting so much memory for other strings that just, needed whatever 16 bytes or so.
Amazing. Awesome. So what's next for you in Rust? What are you going to tackle next?
Yeah, so it's a really strange thing that's happened with me over the last couple of months. I've always liked Python. I've always liked the community, but it's changed in a way that I think I like Rust more because of its honesty, and it forces you to think stricter. So I'm still deliberating what I'm going to really build next. I think the path that I've done from the small Rust platform, bite-sized chunks of contained code, to a guided real project. The next path is something without the guidance, but still a small project, like a coding agent where there's a Python equivalent. So transposing that from Python to Rust, probably that is something. I've also started another project before the cohort started. Before I thought, maybe that. What do I do? And it has some parsing elements in it, or tokenizing elements in it. I called it the privacy stripper. So you have some input, and you with regex you look for social security number, names, with a local LLM, stuff like that, and replace it, sort of pseudonymize it, send it to somewhere else, and then when the response comes back, you de-pseudonymize it and give it to the user. So maybe I do that, but definitely I'm going to do something on Rust. Yeah.
Nice. And
Amazing.
For Pythonistas that want to make the transfer into Rust, I mean, obviously you mentioned the platform, but maybe going from a scripting language, the mindsets, any tips what really worked for you?
Yeah, the concept in languages are comparable. I think it's what's really important is you got to come with a fresh mind and think about learning a new language from scratch. So in the cohort, you have, particularly at the beginning, the way it's implemented in Python. And I caught myself not looking at that anymore because I thought I'm doing this with a fresh mind. In the back of my mind, I have an idea how I would do it in a known language like Python, but I'm trying to learn it anew, and that gives you the step up, really. And then with learning generally is you have to have a rough understanding of what's going on. You can't speak a language if you don't learn the vocabulary. So the open source Rust, or not open source, but the free Rust book, programming book, is really good to get started, to get a feeling for it. But then you got to get your hands dirty. And the Rust platform for me was an excellent preparation for the cohort. Because there as well, you have the Python implementation, and then you do the same in Rust, and that really bridges the languages very nicely. And as you know, then with everything, find your itch. What do you want to tackle? What's a small enough project to just try out tiny pieces and start doing it, and then gradually you learn.
Awesome. Nice. Yeah. Jim, you have any other questions? I ran out of questions. But thanks so much for sharing.
What would you say was your favorite bit of Rust that you learned? Like a technique, a keyword, a block?
I think I go with pattern matching. Pattern matching is so beautiful. Like, you have for instance, an if let, and if let some variable equals, and then you have the pattern. And the way it happens is you jump from what's happened on the left side on the pattern, and if that's the case, then you match it to the sum, the option type in this case, and pull out and bind it to a variable. That is so amazing. I mean, I first looked at it and I said, this code doesn't make any sense. There must be a mistake. If let, they're confusing two subjects, but it's so beautiful, and it's so nice to work with that. That is the pattern matching. Is really the one thing that I now do. Even I do it. I'm not going to say intuitively, but I'm on my way to doing it because it feels so beautiful. And computer languages need to be beautiful. So that's one reason.
That's excellent. Yeah. We forget computer programming languages are not for the computers; they're for us, us humans.
Yeah. Nice.
If you spend so much time with them, might as well love them.
Indeed.
Well, that's, I think, a great place to wrap up. So thanks so much for sharing today, Jochen. And
happy to.
Yes, thank you very much.
We'll be closely watching what you do in Rust, and she keeps speaking it forcefully. And with a lot of passion. So
I mean, Astral's just been acquired by OpenAI, and I mean they invented UV and Rust, and it's all written in Rust. So there's the goals.
Awesome.
We'll see where you wind up on the leaderboard.
Yep.
Awesome.
It better be on top.
We got some fierce competition, so we'll see.
Yeah, I betcha. Yeah.
Awesome.